we can disconnect that call. I'm just doing for others. So, talking about your fundamentals, I'll wait for 2-3 minutes, then join. Okay, you draw this diagram in the meantime. This diagram. Write this down. Least line and hello. Okay. So what is WAN? WAN expands to wide area network. Basically, the internet we are having, right? That can be termed as WAN. Why we are using WAN? To connect two different sites which are not nearby. For example, I have one office in Rajajanagar, second office is in Marathalli. If I want them, the ways I can them. I can either connect. I can either connect using a internet connection. Yes, I can use a Airtel or Vodafone ISP internet. I will connect this site to internet and this site to internet, and by default they can communicate right through internet. That's the first way. Second way, if I don't want to spend so much money, see, think about internet. How much you are paying for 100 Mbps? Maybe I am paying like 700 rupees. But if I'm having like hundreds of computer here also 100 computer here. Is it 100 computer? If I have only 100 Mbps, is it fine? No. I need to have more than 10,000 or 1 lakh. 1 lakh Mbps I should have. Think about this. For 500 rupees, if I'm getting 100 Mbps, if I want 1 lakh Mbps, which is 100 into 1000, so here also it will be like 000, right? So how much I have to pay? 5 lakh rupees I have to pay monthly for internet bill. Is it cheap? No. So what is the second option I have? Second option, I can use something called underground cable. See, you might have seen in the roadside, there are some underground cable which says BSNL, do not dig, do not excavate. BSNL, Vodafone logo will be there. In the roadside, you will see. There's a small stone which they keep. Under that thing, they are having these cables. These underground cables are moving everywhere around the Bangalore location. Okay. So using that underground cable also, we can connect multiple sites. That will be cheap, na? Because underground cable, they are not giving us internet. They are giving us connectivity. We are able to connect this office, that office through underground cable. This is called leased line as WAN, where I'm going to have a dedicated connection between two locations. And because it is not through internet, I no need to worry about hackers and all. Because in internet, if my traffic is moving, hackers might hack my system, na? So in that case, I can simply go with this underground cable. It's a leased line method. Okay. Then he called Ethernet WANs. See, the thing is leased line is that if I'm having two sites, I'm okay with it. Imagine I have one site here, one site here, one site here, and one site here. If I want to connect these four offices using leased line, I connect them like this: one cable, two cable, three cable, four cable, 5 cable, and 6 cable also. Correct? If I'm adding one more office here, then 1, 2, 3, 4. See how many cables I'm running. I'm running a lot of cables here, right? Now, how can I avoid this? I can simply avoid using a switch. If I put a switch here, I switch here, and I just simply connect this cable like this. Over. If I have one more side coming, one cable finished. So if I'm using a switch also, then Ethernet has WAN technology. Least line means one line going from one point to other point directly. Ethernet means it's going through switches. So that it's more cost effective for me. Your name is Jashankari. Who is joined online now? She also left. Others they join on or not? This Shri Narsimha Raju. She's coming. When she will reach? Tomorrow. I'm coming from somewhere else. Other state I came on time. To come at today at 8 o'clock, I had to plan yesterday. I understood this logic, sir. Anyway, I'll share the PPT. Only if you want to note down some important points, note it down, or else this PPT will be given. No problem. So same explained here. Okay, lease line, WAN technology, underground cable. This is how underground cable looks like, as you can see. And Ethernet WAN technology means you can sit there. Ethernet as your name. Your name, Arupashri. Ethernet as a WAN technology means, and I am going to use these switches. Let's see a postman story. And before seeing how routers forward the packet, we'll see how switches work. We'll understand how switches forward a packet using a simple diagram. See, switch forwarding happens like this. So it's very important to understand how switch forward the traffic from one place to another place. So I have taken example of a PC1, PC1, PC2, PC3, PC4. And I've already given you yesterday, you know how MAC address looks like, right? I have given here dummy example of a MAC address. So you have AA MAC address, BB MAC address, CC MAC address, and DD MAC address. These are the dummy MAC address, not original MAC address. Example, for example, A, B, C. I'm telling like that. So imagine that don't have achieve. Okay. So imagine that we have PC1 say leke, I'm sending traffic to PC2. PC1 to PC2, I'm sending traffic. So what will be the source MAC address? PCA's MAC, right? AA MAC. What will be the destination MAC address? BB MAC address. So this traffic comes all the way to the switch 1. It comes up here. Okay. Now, whenever a switch receives a MAC or a packet, right? Switch will do two functions. One, switch informs the MAC table, this table, about source MAC and port. He will go and tell, hey, MAC address table, on port number E1, I received source MAC of AA. He will inform him. Once he informs, second thing, switch will ask MAC table. Switch again will ask MAC table, hey, do you know how to reach destination address? In our case, which is BB. Do you see entry here, BB anywhere? No, we don't see any entry. Imagine I don't know who is Rupashri. What I will do? I'll ask everyone, right? Like, hey, who is Rupashri? If we are full of people. Same way switch will do. Because switch don't know where is BB, he will send the packet to everyone. He will do something called flooding. The term name is flooding. Because I don't know, I am asking everyone. Okay, it's called flooding. Will he reply? No, because destination is BB. I am CC. So I will not reply. Will he reply? Will he reply? When he replies, what will be the source MAC address? BB. Destination MAC will be what? Yeah, right. It come again, this comes all the way to which port number? On port number E2. Switch will do two function, correct? Switch will go and tell MAC address table again, saying, hey, MAC address table, on port number E2, I received a source MAC of BB. Once he informs, then he will ask, hey, MAC address table, do you know how to reach destination address AA? Do you see entry A here anywhere? We don't see AA anywhere. See again. AA. Here it is na AA. Destination MAC address. We see destination MAC address AA here on which port number? On even port number. So reply goes unicast. It is not going to go broadcast. Think like this. You are AA, BB, CC, and DD. A, B, C, and D. I am E. I am asking, I don't know who is A. So I'll ask everyone. When A replies back, for example, you are A. When A replies back, will again A shout everyone, saying that I am A, everyone know, right? She'll reply to only me. So that's why initially it was broadcast. Because I don't know who is A. Reply was unicast. Because now BB, I mean AA knows who is calling. Correct. That's why initially it was flooding. Later on reply was unicast. And that's how switch MAC address table is getting built up. Clear how it works? You can imagine once again thinking about source MAC is CC and destination MAC is DD. Think the flow, how it will go. Okay. Fine. So now we'll go back and we'll see how routers forward the packet. We'll learn. See, for routers, I am going to use a postman formula. So here you have PC1, R1, R2, and PC2. Imagining PC1's interface MAC is XX. Router's interface MAC is AA. This interface MAC is BB. See, whenever you take a device, port will have MAC address, not the entire device. For example, I am the router means this hand will have a one MAC address, one more MAC address. Understood? It's not like my brain is having only one MAC address. Clear? So that's why here I'm writing two MAC address, 1, 2. Here also, this interface MAC is what? CC, this interface MAC, DD. This interface MAC, this interface MAC. Okay. Now let's imagine that I want to pass this packet to you. I am PC1. She is R1. You are PC2. Okay. So I am going to give this packet to you. Now, what will be the destination IP address on this letter? Your information, right? For example, you are C. It will be CC's IP address. So, but to whom I'm going to give now? To her now, not to you, because you're not that reachable. It's only she I can reach. When I give it to her, she will take in the right hand. Right hand will have a MAC address. So source MAC, source IP will be I am. Correct. Destination IP will be you. Source MAC will be my hand. Destination MAC, will it be your hand? Well, I'm going to give it to you? No. To her. So her right hand will be the destination MAC address. Clear? Then when she passed that phone to you from her left hand side, correct? From left hand means on that case also source IP will be me, destination IP will be you, source MAC will be her left hand, and destination MAC will be your right hand. Correct? So this MAC address alone will change. IP address will not change during this path. Understood? So just imagine. So I'm giving it to her now means she have taken from right hand. So source MAC, destination MAC will change. Then again source MAC and destination MAC. This is what will happen here. So from PC1, I want to send packet to PC2. In this location, in this place, what will be the source IP address? 10.001. My IP address, right? Destination IP will be what? 20.002. Source MAC will be what? XX. Now think and tell me. Destination MAC will be what? Will it be YY or XX? So if I'm going to give the phone through her, will I give it to you directly? That's what he's saying, right? You are YY, na? I am XX. Is it going to YY or is it going to be AA? AA, na? Logic the same. So it will be AA. Correct? It came all the way to you. Now imagine that she's a router. Router got the packet. Router is taking the packet and sees, okay, destination MAC is my MAC address only. Let me open the cover. She opened the cover. And inside when she sees destination IP is your IP address. It is not her IP. Then again she has to repack it with different MAC address and give it to you. So when the packet comes from here to here, what will be the source IP address? Source IP, will it change? No. Because source IP is me only always. Source IP will be 10.1. Destination IP, that will be same always. Because if you change that, then I don't know where packet will go. Correct? That will be, IP address will be same. Source MAC will be what? BB, correct. Destination MAC will be what? CC. Now it came all the way to R2 CC. Imagine you are R2. You received the packet. You see destination MAC is, okay, it's my MAC address, your MAC address. You open the cover. Inside destination IP, is it your IP? No. Your R2. Destination IP somewhere else. Okay, then again you will repack it. After repacking, it comes all the way here. Then here source IP will be what? It won't change. Destination IP will be what? Won't change. Source MAC will be DD. Destination MAC will be YY. Simple. So every router is opening the cover. I mean the MAC address cover. It's rewriting the information, right? While opening the cover and rewriting the information. Opening the cover is called decapsulation. Decapsulation. Second is your encapsulation. You buy a food, you open the lid and eat. Okay, that's called decapsulation. Opening and close. Again, you repack it. It is more than encapsulation. Simple. Okay. So now you understood why MAC address is changing. Huh? IP address will not change. If IP address changes, letter will go somewhere else. Correct? You should not change IP address. You should not change source IP and destination IP, anything. Okay? We are not changing. Am I changing this hand MAC address? This is same MAC address, right? You are replacing the MAC address with different hand because to hand over that letter. Am I changing my XX MAC address? No, it is same always. It is XX only. The packet we are changing. Okay. Is it clear how router works and switch works? Okay. Now you can imagine for 3 to 4 minutes, whatever I told, and you write the information. Imagine this IP address is 11.001. Here it is 12.001. And imagine this MAC addresses as A, B, C, D, E, F, and write down in these places what will be the source IP, destination IP, source MAC, and destination MAC you will get. Understood what I said? Write it. Written? Okay. So now you understood how switch communication works through a MAC address table and how routers forward the packet and what are things changes. Like MAC address alone changes in every hop, but IP address will not change. Let's talk about some of the addressings which you already seen yesterday. So we have mainly three types of addresses in networking. We have IPv4 address, IPv6 address and MAC address. When you say IPv4 address, it's a 32-bit binary number. IPv6 means 128-bit binary number. MAC address means 48-bit hexadecimal number. It is not binary. It is hexadecimal. This is how an IPv4 looks like. It will have 4 numbers, and these numbers will be in what range? 0 to 255 max. And IPv6 will looks like this. It will have 8 quadrants. Quadrant means 4 number. So 8 quadrant means 1, 2, 3, 4, 5, 6, 7, 8. 8 quadrants. Then you got MAC address. It will have 6 blocks. Okay, 2 to each. And it is made up of hexadecimal number. Now we will learn about binary, decimal, hexadecimal. Let's see. See, in networking, there are 3 major numbering systems. Private IP will be from 10.xxx, 172.16.xx, 192.168.xx. This will be the private IP range. Like 10 dot anything is private. 10.001, 10.1.13, 10.128.196.213 private only. In this range, 172.16 all the way to 172.31.xx. In this range, any IP address you are getting, private IP address. 192.168, anything is private only. For example, if I tell 192.168, 15.14, private. If this value you are seeing on IP address, then it's private. This is going to be 172.16 XX all the way to 172.31 XX. This will be the private IP range. Write this down. It's not in notes. Finished? This you have to mug up or by heart. Why is what to do down? Understood? So class A 10 dot anything, class B 17 to 16, all the way to 17 to 31 anything. Class A means 19 to 168 dot anything. Let's see compare decimal numbers. So in networking, there are 3 major types of numbering system. One is called decimal, second is called binary, and third one is called hexadecimal. When you say decimal, 0 to infinity is decimal numbers. But for network engineers, it is 0 to 255. It's always decimal. Binary means what? Zeros and ones. Hexadecimal means 0 to 9, then A, B, C, D, E, F. 0 to 9, A, B, C, D, E, F. 1 decimal is equal to how many binary bits? 8 binary bits. 1 hexadecimal is equal to 4 binary bits. Let's understand to convert decimal to binary. If I give you a number 26 and ask you to convert that to binary, you will convert like this only. See, one decimal is equal to how many binary bits? 4, right? Sorry, 8. It has a 8 has a values like ones, 1, 2, 4, 8, double 16, double 32, double 64, double 128. Like just multiply by 2 to 2. And it has 8 values 1, 2, 3, 4, 5, 6, 7, 8. It has. So if you get number 26, what number I should add here? Tell me. 26 means 16 plus 8 plus 2. 16 plus 8, 24, 26. So 0, 0, 0, 1, 1, 0, 1, 0. If I give you 26, the binary value is 0, 0, 0, 1, 1, 0, 1, 0. Simple. Now convert this, what you will get? 18. 16 plus 2. That's all. So 0, 0, 0, 1, 0, 0, 1, 0. Simple. Now you convert both of you guys 89 and 56 and give me the answer. Till 89, 60, 80, 88, 89, 0, 1, 0, 1, 1, 0. 32, 48 plus. Okay, got it. So now you understood, right? How to convert decimal to binary. Similar way, can you convert this binary decimal also? Ulta? Do that and give me the answer. What you will get? Hmm. 17, huh? What is the answer? First one? Second one is 1, 7, 0. Okay. 51. Okay, got it. Correct. That's a simple one. So let's see. See, initially, when the internet or networking was introduced, the entire IP address segment was kept in one single block. For example, IP address consists of 4 numbers, right? XXXX. And what is the minimum number I can get? 0.0.0.0. Maximum is what? 255. 255. So initially, the entire range from 0000 all the way 255, 255, 255, 255. This was part of a single network. Later on, we divided them into 5 pieces. We divided them as a class A, class B, class C, D and E. Based on the first number, we divided them. If the first number is in the range of 0 to 127, it's called class A. 128 to 191 means class B. This means class C, D, E. Only class A, B, C I can use in a computer. Others we cannot use. D and E we cannot use. It's used for something else. We'll see it later, not now. Now, based on this, can you tell me which class is this? This one? C, C, C or D, D or C, D or C, C. Correct. C. So it's very easy now to understand, right? But you have to by heart this. Write this down once so that you can remember. This range you have to by heart it. Clear? Now we'll understand something called subnet mask. Now, why do we use subnet mask? See, in a given IP address, there are two things that are hidden. One is called your network portion, and second is called your host portion. There are two portions. One is called network portion, and second is called host portion. Network portion, and to find out network portion, host portion, we use subnet mask. And these are the default subnet mask we are having. Okay. For example, it's a class A, right? So class A submask will be what? 255 dot. This says that wherever you see 255, right? Same portion here is network ID, network portion. If you see zeros here, last three portion is zero. In IP address also, last three portion is your subnet, host portion. So it is network portion, it is host portion. You just take this and put on top of IP address. Whichever number comes below 255, network portion. Whichever number comes below 000, host portion. Let's try one more time. This is what? Class A. Class A means what I'll get? 255. Okay. If I take this and put on top of this IP address, below 255, what I will get? Which number? Below 255, which number I'll get? 15 I'll get. So network portion is 15. Below 000, what I'll get? 0009. So host portion is simple. Let's try one more time. This is first class. A or B? 145. B. So what will be the subnet mask? 255. So take this, put on top of this. Below 255, what I'll get? 145.1, right? So network portion is what? 1. Host portion will be what? 7 point. Easy. So let's try last. You do this and give me the answer. In 123, tell me which is network portion, which is host portion. Is it class B? Is it class B? Class B? Class C? Class this one? Class B? Ayo, decide first. Class A? Correct. Now you are correct. Class A. Now what I will get? 255. Network portion is what? 123. Host portion? 1.2.3. Easy. Now you tell me for this one. What you will get, both of you guys? Host portion? Oh, correct. Easy. That's all. You wrote this also not. So that is the use of your subnet mask. Now don't ask me why we are doing this. Not required. We'll see later. As of now, you understand how we are doing that. Okay. Okay. Now I'll give you two things. See, in networking, there are two devices. One is called your switch, second is called your router. Switch, we represent with the box, two line switch. Router means circle, cross, router. See, whenever you have two devices with same network portion, you have to use a switcher. If you have two devices with different network portion, you have to use a router. I'm going to give you two IP address. You tell me, is it? I'm going to give you two PC. I'm going to take. I'll give PC1 IP, PC2 IP. You tell me what device I have to use, router or a switch. Okay? Why? I have to give IP address. Wait. I'll give IP address. 10.001. Here, 10.002. First, you have to find out the network portion. Network portion is what here? In 10, huh? Network portion is 10. Here, network portion is what? Is it same or different? Same means what device? Super. Switch, correct? Next, I have one more time. 10.001. 172.16.1.1. Now, why? Network portion is what here? On that one? 172 dot class B, na? So 116. Is it same or different? So different means routers. Understood? So that's why we are studying subnet mask. Because subnet mask help us identifying network portion and host portion. After identifying that only, I can decide whether it's going to be a router or a switch. Clear? That's it. We'll go for a break of 10 minutes. If you have any questions so far, please ask me. Any doubts or question? No? Okay, then break.